And in parentheses, after I write conic, I'm going to say not linear conic, since we did talk about that a line can be considered a conic. So linear with a conic system. So first thing I want to know is how many solutions can a system of equations have if one equation is a line and the other a conic that's not a line. Always two? Two or less than two. I like that. Anybody have any other answers? Okay, let's see. We can have a circle, right? And a line, and they cannot touch at all, right? So wouldn't that be no solution? So no solution is always an option. We can have our circle and I can have my line touching exactly once if it's tangent, right? So that's a one solution. So we could definitely have zero solutions. We could have one solution. I can have two solutions also, right? Right here. That's two solutions. So you could have no solution, you could have one solution, you could have two solutions. Can we have three solutions? No. If I were to take that line and cross it through the center point, would that center point count as a solution? No, because the center point is not actually the rim of the circle. For it to be a solution, it's where our line crosses the outside of whatever the graph is. It's where they intersect. So that center point would not count. So a lot of you said two or less, right? So we can have at most two solutions. You can have less than two solutions. You could have one solution. You could have zero solutions. But can we have more than two solutions? No, there's no way to draw that line and a conic where it intersects more than just twice. All right. So now what we want to do is we want to solve these systems of equations by graphing and also algebraically. So let's just jump right into this. So I'm going to say sample problems. And for the first problem, I want us to solve by graphing. Yes? Okay, solve by graphing. Let's say I have x, the equation x equals the quantity of y minus 2 squared, and I have the equation x minus 2y equals negative 4. Okay, the first thing we want to do is figure out what kind of graphs do we have here? That x equals the quantity of y minus 2 squared. What is that? All right, I couldn't hear you. Yeah, it's a horizontal parabola. Perfect. So we have a horizontal parabola. What's x minus 2y equals negative 4? What is that? A line, because nothing's squared on it, right? So it has to be a line. So the first one, this horizontal parabola, is in a good format. This is absolutely in the x equals a times y minus k quantity squared plus h. Of that whispering is very loud.
Really, really loud. You're like putting so much air into it. You're like that.
All right, guys, we're being recorded.
A little bit loud.
Okay, so now what we want to do is x minus 2y equals negative 4. We know it's a line because there's nothing squared on it, but is this in the format that we want for a line? No, we want it to look like slope-intercept form, y equals mx plus b. So I need to get y all by itself. So the first thing I'm going to do is I'm actually going to add over the y to make it positive. So I'll have x is equal to a positive 2y minus 4. Then I'll add the 4 over. So we'll have 2y is equal to x plus 4. And then I'll divide every term by 2. And we'll have y is equal to a half x plus 2. And now I have my two equations in proper format. My next step is to graph this. On the test, if I ask you to graph, our solution is going to be which points? Like, how would I know? So if I graph these two things right now, how will I know what points are my solution? Good. It's going to be where the two graphs intersect. And I will promise you this. The points where they intersect will be normal integer coordinates. It's not going to be like if I'm asking you to graph. If I'm asking you to graph, it's not going to be like the square root of like 121 or 123 or something like that. Okay. So it will be nice integer numbers. So let's go ahead and start graphing. So for the sideways parabola, horizontal parabola, do we all agree our center is going to be the point 0, 2? So I'm going to plot that, 0.02. And now that point is my center. Oh, sorry, not the center, the vertex. I called it the center. This is the vertex. That point is the vertex. But isn't it also the y-intercept? Vertex and the y-intercept. So now since I know it's the y-intercept, I'm not going to solve for the y-intercept. The other thing I'm going to find is the x-intercept. And to find the x-intercept, don't I plug in 0 for y? So we're going to have x is equal to 0 minus 2 squared. So the x-intercept is 4. So I have the point 4, 0. So there's another point of my parabola. Now remember, isn't there an axis of symmetry right through the vertex? Oops, where'd it go? All right, there's an axis of symmetry right through the vertex. And because from that axis of symmetry, I have that x-intercept at 4, 0, that's 2 units below the axis of symmetry. So can I create another symmetric mirror image above that axis of symmetry, 2 units above it? So now I have, 3 points. And I hope that's enough. If I need more points, how would I get more points if I needed them? Plug in values for x and find the corresponding y. But we shouldn't need more points. We hope this is enough. So now we're going to go and I'm going to graph my line. Do we agree that the slope of this line is 1 over 2 and the y-intercept is 2? So when I go to plot this line, I'm going to first plot the y-intercept, which is 2. And right there, me plotting my first point, what do we realize? It's a point of intersection, which means there's at least one solution here. It's not going to be a no solution. So now from there, I'm going to use my slope to create more points. So the slope says rise up 1 and go to the right 2. So up 1 to the right 2. Did something go wrong here? Is my slope wrong? Nope, we're okay. Up 1 to the right 2. Then we're going to go up 1 to the right 2 again. And then on the other side, I'm going to go down 1, left 2. So it looks something like this. How many points of intersection do we have? 2. So how many solutions do we have? 2. So my solutions will be the points where we intersect. So the solution will be the point 0, 2, and the other point is the point 4, 4. Okay, so my promise to you is if I have you solve by graphing on the test, all the coordinates that will be a solution will be integers, no crazy numbers. Okay, so now we're going to solve algebraically. So step number 2, or sorry, problem number 2, we're going to solve algebraically. Okay, now when we solve a system of equations algebraically, we have 3 ways to solve. We have graphing, which we just did. We have elimination, which is usually my favorite method is elimination. And then we have substitution. Unfortunately, even though it's my favorite method, I will not be able to solve this through elimination. Why not? Why is that not the preferred method here? Excellent. Because I have x squared, y squared, then I just have x and y. They're not the same. They're not like terms. They're different exponents. So solving through elimination is not the recommended way. So what do I recommend? How do I recommend we solve this? Through substitution. So if we're going to solve through substitution, what are we going to do? Your first step that you're going to do is solve the linear equation for one of its variables. Why do you think I so specifically said solve the linear equation and not the circle? Good, because in order to solve for one of the variables in the circle, I would have to take the square root. And that gets a little bit sloppy. If I solve for one of the variables in a linear equation, I'm not having to take the square root. So it's nicer, it's neater to work with the linear. So now looking at the linear equation, one of these variables is the better variable to solve for. Does anybody know which one is the better variable? Justin. Good. Why is y the better variable? Excellent. Because there's no leading coefficient, we're not going to have to divide, which means we won't have to potentially deal with fractions, which is better. So if I'm going to get y all by itself, I'm going to say that y is equal to a positive 2x minus 1. Hi. I do.
Was she looking for this?
She was not, but you guess she saved the day before she was. Thank you. No, not at all. It,
Call you.
appreciate it. You too. Okay, so it says solve the linear equation for one of its variables. We're solving for y. We got y all by itself. Our next step is going to be take the manipulated expression from step 1 and substitute it into the other equation. Okay, so what does this mean? Take the manipulated expression, meaning I solved for y. So I'm going to take the expression of what y equals 2x minus 1. I'm going to go to the other equation. What's the other equation? The circle. And go to the other equation. Wherever I see y, now what am I going to sub in instead of y? 2x minus 1. Exactly. So now we're going to go to our other equation, and we are going to have x squared plus, now instead of y, I'm putting the quantity of 2x minus 1 squared equals 13. Tell me, am I allowed to do this? Square root both sides and get x plus 2x minus 1 equals square root 13? Good. Why no? Why am I not allowed to do that, Stephen? Because of the plus sign. Had there been multiplication between them instead of a plus sign, then could I do that? Yes, but I can't, so I will. So now, since I can't square root both sides, I'm going to have to expand this left side. I'm going to have to FOIL out 2x minus 1 quantity squared to combine my like terms. So I have x squared and then 2x minus 1 times another 2x minus 1 equals 13. So now we FOIL. So we have x squared plus 4x squared minus 2x minus another 2x plus 1. Combine our like terms. So now I have 5x squared minus 4x plus 1 equals 13. What does it look like I could potentially do now? It looks like I could potentially factor. If it ends up being that I cannot factor, factor is always the quickest. If it ends up being that I cannot factor, then how would I solve for x by using what? Quadratic. Very good. In order to factor this, what must I set it equal to? 0. So we're going to have 5x squared minus 4x minus 12 equals 0. So now I try. Luckily for me, 5 is prime, so we don't have many options there. We have a 5x and an x, really no other numbers would split that. So now we look at factors of 12. We have a few factors of 12. We have 6 and 2, we have 12 and 1, and we have 3 and 4. What number do you want to try first? Okay, let's go with 6 and 2. I'm going to write it wrong. I'm going to put a plus 2 and a minus 6 just to show you. This is wrong. You have to check the middle term. 5x times negative 6 is a negative 30x. 2 times x is a positive 2x. Is negative 30 and a positive 2x ever going to get us to a negative 4? Never. So guess what I'm going to do? I'm not going to go different factors. I'm going to switch my factors. So I'm going to go positive 6x and negative 2. Let's check this. So now we're going to have 5x times negative 2 is a negative 10x. 6 times x is a positive 6x. Does that get me to a negative 4x? Yes. So we have our winners. Now what we need to do. No, you're cutting my flow. 1 second. Now we're going to solve for x. Just let me solve and then you could ask me, okay? 5x plus 6 equals 0. X will equal negative 6 over 5. And then this one, x minus 2 equals 0, x equals 2. Yes, Rika?
Because, like, what if you didn't recognize that they could have been?
I know, but that quadratic equation is going to take you, it's okay if you get the right answer, but it's going to take you much longer. But yeah, it is okay to answer your question. It is okay, but it's going to take you longer, and then it's going to be a lot sloppier to find the right answers. Okay. So am I done here? Is this problem done? No, when we're solving a system of equations, we're looking where for the points where the two graphs intersect each other. I just have two x coordinates. What do I need to find? Their corresponding y coordinates. So your last step, oh, sorry, we skipped a bunch of steps here. Step number 3, solve for one of the variables. And then step number 4, substitute answers from step 3 to find remaining variable. Justin, could you stop humming? Do you guys feel that Justin feels safer now? He hasn't put his fort up in a while.
After the moment beside the word, going back up.
Have we created a safe space for you? Is it because of me and my expertise in creating safe spaces? Thank you. All right. So now we're going to solve, now that we have our x values, we're going to solve for y. I'm going to go back to y equals 2x minus 1. So we're first going to use x equals 2 because it's easier. So we're going to have y equals 2 times 2 minus 1. So y will equal, was it 2? Yes, x equals 2. So y will equal 3. And now we're going to use x equals negative 6 over 5. So I'm going to have y equals 2 times negative 6 over 5 minus 1. So y is going to equal negative 12 over 5. I'm going to make a common denominator, so I'll put that 5 over 5. So y will equal negative 17 over 5. How many solutions do we have here? 2 solutions. We're going to say 2 solutions. And our 2 solutions will be the point 2, 3, and negative 6 over 5, comma, negative 17 over 5. Okay, so that was talking about when we have a linear and a nonlinear conic. Now let's talk about conic-conic. Yep, both nonlinear. So my first question is going to be, how many solutions can we have? If it's not the same conic. So Justin's saying 4 or less. Does anybody have another guess? Well, if it's not the same conic, if it's not the same exact conic. Okay, let's see. So the only offer we have right now is 4 or less. Nobody is countering that. Okay, let's see.
Oh, if it's the number 2-1.
All right, we could have no solution, right? Can we have one solution? Can we have two solutions? Can we have three solutions? Yes. Oops. Want them up there. This looks a little weird, but we get the idea, right? Can we have four solutions? Can we do 5 solutions? I can't think of anything. So what does that mean? 4 or less. Exactly. So did Justin win? Justin won. Okay. So let's do our sample problems here. We want to solve by graphing. And the first one's x squared plus y squared equals, oh, no, that's not the one. Sorry. Oh, yes, x squared plus y squared equals 1. And x squared over 4 plus y squared equals 1. What conics am I dealing with? An ellipse and a circle. Do we agree that they're both in good formats? I don't need to manipulate anything. So for the circle, my center is 0, 0. What's my radius? 1. For this ellipse, so this is a circle. For the ellipse, what kind of ellipse is it? Horizontal. And do we also agree the center of this ellipse is 0, 0? If they have the same center point, does that count as a solution? No, it does not. And do we agree my A is 2 and the B is 1? Okay, so let's start sketching. Okay, so the center for the circle is 0, 0, and we're 1 unit radius, all left, right, up, down. So our circle looks something like this. Now for my ellipse, my center is 0, 0. We already said that does not count as a solution. And my major my semi major axis is 2. So I'm going to go up to, it's horizontal. So I'm going to go left 2 from the center and right 2 from the center. And my semi minor axis is 1. So that means I'm going to go from the center up 1 and from the center down 1. How many solutions do we have here? 2 solutions. So one solution will be the point 1, 0. Oh, sorry, not 1, 0, 0, 1. And the other one is 0, negative 1. Guess what we're going to do now? Solve algebraically. So let's do a problem where we solve algebraically. This is our last problem for today. You do have homework, yes. Can someone tell me why I would be able to solve this through elimination? Does anybody know? Tyler? Good. They each have an x squared. Because they have even one variable that's considered like terms, we can use the elimination. So let me show you how. Could we still use substitution if we wanted to? Yeah, for sure. But let's go try elimination. So I'm going to have x squared plus y squared equals 13. And then I'm going to line it up with x squared minus y equals 7. Because I want the x squareds to cancel, I'm going to distribute in a negative, so that changes all of the signs. And then I go ahead and I add. When I add a positive x squared and a negative x squared, they cancel. Am I able to add y squared and y and make that like a 3y squared? No, they're not like terms. So the way we write this is just y squared plus y equals 13 minus 7, which is 6. Oops, why did I write y squared twice? Y squared plus y. There we go. What can I potentially do here? Factor. In order to factor, I must set it equal to 0. Y squared plus y minus 6 is equal to 0. So we're going to go y plus 3, y minus 2. So we get y equals negative 3, y equals positive 2. Am I done? No, why? We have to find the corresponding x coordinates. So right now, it's on track to think that we have how many solutions? 2. But that does not mean that we will actually have 2 solutions. Let's see what happens. So I'm going to go back to one of the equations, x squared minus y equals 7. And now I'm going to start with the y equals negative 3. So we're going to have x squared minus a negative 3 equals 7. Doesn't that double negative make a positive? So now we're going to have x squared, I'm going to subtract that 3, equals 4. Now, when we're solving and we have to take the square root, what must I account for? Plus minus. So guess what? this is right here, two solutions on its own. It's a positive 2 paired with a negative 3, but isn't it also a negative 2 paired with a negative 3? So that alone is two solutions, and I'm still not done. So now I subbed in y equals negative 3. Now I'm going to sub in y equals 2. And so when I sub in y equals 2, we're going to get x squared minus 2 equals 7. X squared equals 9, so x will equal plus minus 3. So now we're going to have plus minus 3 comma 2. How many solutions do we have? 4 solutions. We're going to have plus minus 2 comma negative 3 and plus minus 3 comma 2. All right, kids, we are done for today. How much